Today I will explain to you last class notes which say that differentiate a function with respect to x. Question is sign, and then inside the bracket I have x squared plus 5. Answer: d by dx of sign and then bracket x squared plus 5. Here in the sign I don't have any square or cube, so I will not use formula number 1. So here we will have to use with formula number 3, which say that d by dx of sine of x equal to cos of x and then dx by dx. Dx will always remain the same, d will always remain the same. So in this case, when you compare this one with the formula, sine and then we have x squared plus 5 and then sine of x. That means wherever x present, I have to replace it with x squared plus 5. That means in place of this x here, I have to write x squared plus 5. In place of this x here, I have to write x squared plus 5. Whereas d by dx remain the same. So in the next line, I'll have cos of x. That means I have to write x squared plus 5. And then d by dx remain the same. And then again, x I have to write x squared plus 5. Now in the next step, cos x squared plus 5 has come outside. That means it will remain the same. Now what I have to differentiate is that d by dx of x squared plus 5. You have to remember that in the property it say that when I have many function, I have to differentiate each and every function. In this case, what are the function? Function is x squared and then the second function is 5. So what I'll have here, that means I will enter d by dx for both the term. I'll have d by dx of x squared plus d by dx of 5. Then in the next line, I'll have here cos of x squared plus 5. I have to differentiate this term in a bracket. D by dx of x squared, this one is by using formula number 1, which say d by dx of x power n, you will have n and then x power n minus 1 dx by dx. That means in this case, I'll have x squared. That means your n will be 2. So I'll have here 2. X in this case is x itself. That means it will remain the same. And then n minus 1. That means 2 minus 1. And then dx by dx. X here is the same. So it will remain x only. It will get cancel. Plus d by dx of 5. This one is by using property number 2, which say d by dx of constant equal to 0. That means any constant number. Here in this case, I have constant number 5. That means it will be 0 when I differentiate a constant number. And then in the next line, I'll have cos of x squared plus 5. And then 2x power 2 minus 1, I'll have 2x only. Because 2 minus 1 will be 1, I'll not write 1. And then plus 0, I will not write it anymore. That means that one on me. Which is equal to 2x, I'll bring it in front. 2x. And then I'll have cos of x squared plus 5. Question number 2. Cos of sine of x. Answer: d by dx of cos sine of x. In this case, which formula I have to use? I have to use the formula of d by dx of cos of x. I will not use formula number 1 because we don't have any square or cube here. So directly I will use the formula of cos of x, which say it is equal to minus sine of x dx by dx, which is equal to minus sine. But in place of this x here, what I'll have in this case? What is my x in this case? I have x here, sine of x. That means I'll have sine of x. And then d by dx remain the same. This x on the numerator, I have replaced it with x. What is our x in this case again? Sine of x. Which is equal to minus sine and then sine of x. D by dx of sine of x, formula is cos of x and then dx by dx. When I differentiate sine, I will get cos of x. Our x in this case is the same x itself. That means I'll have cos of x. X is the same x. That means dx by dx will remain the same. It will get cancel. Which is equal to, you can arrange it, bring the cos x in front, cos of x, and then I'll have sine of x.